This is exercise 4.5, question 14. Now, in the diagram, we are told that VW is equal to VY. I won't put markings on that because we've got this other line UX cutting across, and so that's VW equals VY. Now, just thinking about that we've got this triangle here, VWY. If VW and VY are equal, therefore we've got some base angles there that are equal. We've got this angle here at W is equal to this angle here at Y. Now, what we'll do, let's just call this angle up here alpha. So what we're going to do, just by what we've spoken about and just what we've looked at, is that the angle down there as well would be alpha. So let's just write that up in a minute. And we're also told that UX is perpendicular to WY, so we've got a right angle there. And what we have to prove is that UVZ, so this triangle here, that it's isosceles. So we're going to have to prove that we've got, basically, we can see we've got some angles there. We're going to have to prove that two of the angles in this triangle UVZ are equal. So let's write down this information that I was speaking about before. Because VW equals VY, then angle VW X, if we let that equal alpha, that it equals this angle down here. So let's start with that. So let angle UWY equal alpha. And we also know that, as we just said before, that angle VYW, this angle down here, will also equal alpha because they are base angles of isosceles triangle. We should say which triangle we're talking about as well. Triangle VWY. I'm going to have to move this all over. And the reason that it's the isosceles triangle is that VW is equal to VY. So we've got the two alphas marked in there. Now we're going to have to try and work out some angles here in this triangle UVZ. We do have a right angle triangle here. So triangle UWX has a right angle there at X. So if this is a right angle here, then alpha plus this angle down here at U must also equal, they must add up to 90 as well. So writing that down, we know that angle WUX must equal 90 minus alpha because it's the angle sum of triangle UWX. And I'll just put that 90 minus alpha in now. I can't quite fit it there, so I'll put a little arrow in there to mark the angle. So just moving that little arrow in now. Oh, things aren't. So this angle in here is 90 minus alpha. Now we also need to find another angle in this triangle UVZ to show that it's isosceles. Now we do have another right angle triangle over here. We've got triangle XZY and we have a 90-degree angle there at X, and this angle here at Y is alpha. So therefore this angle here at Z, which is angle XZY, must be 90 minus alpha because of angle sum of that triangle. So we can write that down as well. So therefore angle XZY equals 90 minus alpha. So this angle in here is 90 minus alpha because it's the angle sum of triangle XYZ. Now you do need to say which triangle you're talking about because we have many triangles here in this diagram. I'm just going to mark this angle here at Z on the diagram. So as you can see, I've marked this angle here, angle XZY is marked as 90 minus alpha. So we can see we've got two lines crossing here, so we can see that this angle in here, angle VZU, would also be 90 minus alpha by vertically opposite angles. So I'll just mark that in on the diagram, that this angle in here as well would also be 90 minus alpha, and we'll just write that up as well. So angle UZV, so UZV equals 90 minus alpha as well, because we have vertically opposite angles. So now we've shown that two angles in this triangle are both 90 minus alpha, so we can write that down as well. So angle WUX, or you can even call it angle VUZ if you want, is equal to angle UZV, and the reason is that they are both equal to 90 minus alpha. Hence we can say that triangle UVZ is isosceles, because we have two equal angles. And that is the end of question 14.